start for the second half of this lesson. I just recently heard that some people can't find the things. Can't find the syllabus. If you go to, yes, here it is. If you go to github.com/usedecoders/2018-0618, I'll stick this link inside of the Etherpad so everyone can see it. And actually, no, I'll just do this whole thing. Inside of this directory are 3 files, including the challenge answers for some reason. Please ignore those. The syllabus that I'll be going through today is just under 2 data analysis, which is great. So if you wanted to follow along as I type it out, that's entirely great. As for what I'll be teaching you today, we'll be going through, we'll be reviewing some of the concepts that you saw in the morning session, but this time we're going to go through it a lot slower and really go through exactly what's happening behind the behind what it's outputting, in order to really understand exactly how it's doing what it's doing and how it interprets what you're placing. In addition, we'll be going over the various different types of data that Python can store, whether it be strings, integers, floats, lists, tuples, and dictionaries. Don't worry, I'll explain what all of these mean, and as well as going through data frames and basically using Python to do many of the same things that you might do in Excel or in Google Sheets. So to start, as you saw in the morning session, Python can be used as a calculator. You can do very simple operations such as 1 + 1. Should probably ask, can everyone at the back see this just fine? Okay, great. And all the familiar operators are all there. So 1 + 1 = 2. 2 times 2, well, so 2 times 3 is 6. 4 - 2 is 2. In addition, Python will also understand order of operations. So let's say I went with 1 + 8/4. Oh, that's not useful. We can see now that the answer is 3.0. And does everyone remember how to get Python to execute commands? Just put up your red sticky if you're having problems recreating this output that you see at the end over here, or your yellow sticky if it's verified. So 3.0 is because it understands that what I tried to do was some arithmetic. In particular, I put the divide sign, and it understands then that the answer could be a decimal place. And as a result, it tries to show me the results with including the decimal. That is particularly good point if I did like 9/2. We'll go 5.5. And of course, it does more than just one decimal place. If I did like 10/3, it'll show however many decimal places as it wants. So that's order of operations. The next part, sorry, can everyone put their stickies down just for the next part? So text. This isn't so relevant inside of Jupyter where you can just type whatever you want. But say you wanted to make a note inside of some piece of Python code. So normally, if I tried to do something like I = 3, and then I tried to say like this sets 3. Oh, sorry, I should probably do like 3 times 3. This multiplies by 3. You'll notice that it throws a syntax error and it refuses to show anything, and that's because it tries to interpret all of this as Python. And this English sentence down here is not valid Python code. So in order to show up as code, we put a number sign or hashtag or pound sign up in the top. And you can see now it doesn't execute anything that's after the number sign. And so this is a comment, I should probably say. I should also note there is the power of operator, and the power of operator is the star or times times. So this is 3 to the power of 3. 3 to the power of 3 is 27. Now then, up to this point, all of the commands that we've done so far, I'm just going to scroll up a little bit. All the commands that we've done so far have just been printed out into the screen. But we haven't actually saved these results anymore, except for the fact that they display right over here. If I wanted to, I can save the results of some of these computations. For example, what I'll do is I'll save these computations inside of something what's known as a variable. And these variables will store whatever you put inside of them. So let's say I call a variable, and you can use whatever name you want, I equals 3. And the very first thing you might notice is that nothing is out. That's because we captured the output of, let's say, like 3 times 3. We've captured the output of this expression inside of this variable. And as a result, it no longer displays. If I wanted to display it, all you have to do is recall the name of the variable, I. And you can see that it recalls that, oh yes, I is equal to 3 by 3, which is equal to 9. You can do various things with this variable. For example, I times 2. Voila. It recalls that I is 3 by 3, multiplies that by 2, you get 18. You can think of this variable right over here as just sort of like a nickname or a shorthand form for whatever you wanted to store inside of it. And of course, your variable names can't really have spaces, and it can't start with a number, but you can include underscores, yeah, you can do underscores, you can have capital letters, anything beyond that is fair game. These variables can hold various different types of data. Now, up until this point, all I've been storing are numbers, which is fine, and it understands that. I can also store other types of variables, such as strings. What strings are, I'll just call it string variable, is equal to, what strings are their pieces of text. In order to signify that I'm going to give it a piece of text and not something that it has to evaluate, you put in these either the double quotation marks or single quotation marks. Here I'm showing double quotation marks, and I can type whatever in here. And you can see now if I enter string score. Remember to switch this from Carpentry. It can recall the entirety of the sentence. And in fact, it doesn't actually matter whether or not I put double quotes or single quotes. You can see over here, it's converted it to single quotes, but in actuality, they just do the same thing. The result of this, of recalling what the string variable is the exact same thing. Other cool things that you can do include, suppose now that I had another string variable is equal to other text. I want to see, I want to basically add these two together. And as you can probably guess, the result is going to be the first string, which was I can type whatever in here, plus the other string, other text. You can see that it didn't really add in the space or anything. And that's because it just took the two strings, which didn't have a space at the end or the front, and it just sort of pushed them together, just like so. If I needed to add that, I can just add in a space. Note that I, again, have to put in these quotation marks so it understands that there's an actual space in here, because otherwise it won't understand what to do. And there you go. I can type whatever in here, space other text. If I omit this, it's going to give me an error. So do recall to place the quotation marks. So I've sort of glossed over that there are different types of variables. So yeah. And in order to figure out what type of variable is inside of, what type any variable is, so you might recall that I had I and new variable are numbers, and string variable 2 are text. But we can also just ask the computer to remember that for us. we could say type of I. Here we can see that I is an integer, where integers are whole numbers only. If I do type of what was it, new underscore variable, but that Python is case sensitive, so you will have to copy whatever capitalization for. And you can see that again. Oh, sorry, to the top. It says it's an integer. If I put in string underscore, actually, let's just right, string variable. You can see that it says str, which is just shorthand for string. And as the question I got earlier, what happens if, like, why did it show a decimal point after you use the division sign? So let's say 5/2. It's 2.5. Actually, let's do 4 divided by 2 is 2.0. What happens if I store this inside of another variable? We'll call it floating. And I do type floating. So the answer is a floating point number. That just means that it understands that it's not going to be, or it's not necessarily a whole number, and that it's, yeah, it's a float for floating. As I've said before, the assigning a variable like this captures the output of this. So when I say floating is equal to 4 divided by 2, it computes 4 divided by 2 and stores it inside of floating. And the reason why there's no output is because the last thing either has to be an expression, which is to say like some mathematical expression, or just the name of the variable in order for it to print anything out. So floating is equal to 2.0, but floating is equal to 2 divided by 2 won't display anything because the output got captured and then it's stuck inside of that variable. Python also allows us to use to do comparisons. And this might seem a little bit trivial at first. Let's say 5 greater than 2 is true. And if I store this inside of a variable, and I figure out what the type is, you'll see it says bool. Bool stands for Boolean, and it just refers to a variable that can either be true or false. And of course, this is a trivial example, but the reasoning behind it becomes a lot clearer if you do something like floating greater than 1. And in case you can't recall what floating is, it can tell you, or floating here is set to 1. But by using this comparison, we can see that 1 is not greater than 1. Nice. Another thing we can do is we can invert a bool, which is to say we can do not floating greater than 1. And you'll see that the answer is true because floating is not greater than 1, but it's not that, and then it becomes true. We can also do more complex expressions, such as say 1 is greater than 2, or 2 greater than 1. And what this does is it calculates the left-hand side of the OR, which is 1 greater than 2, which is false, and 2 greater than 1, which is true. And it does the Boolean OR. And how that works is the OR operator gives you a true output if either the left side or the right side is true. So I'm just going to, let's say A is equal to 2, B is equal to 2, 1. You can now do stuff like A or B, which the utility of this will become more useful later. But you can also do things like the other Boolean operator is and what that does is it gives us a true value only if A and B are true. So the mnemonic there is A and B or A or B. To give you a better idea of how these work, so let's say I'm just going to do true true. So if both of them are true, A or B will be true. If one of them is false, we'll get true. Both of them are false. A or B will give you false as the output. Sorry, am I going a bit too fast? Should I slow down a bit? Yes, you can. C is equal to true. And since at least one of these is true, voila, it's true. And of course, you can do the same thing with A and B and C, and we get false. Order of operations is it goes left to right. So A and B is executed first, which gave us false. I'll just put this in comment. A and B, false. C. So the order that it's doing it is it starts off with seeing A and B or C. It executes the first run, which is A and B, which gave us false. And then it did this false or C, which is equal to true. And the final output is true. Sorry, raise the font. Cool. Can everyone in the back see this okay? Is that a no? I can go one further. Oh, sorry, scroll up a bit. Okay. How far up? Oh, okay, got it. Like this? Awesome. Just a little quick test. I'm actually gonna, sorry, scroll down again. Let's set A is equal to true, B is equal to false, and C equals to true. Can anyone tell me what'll happen if I execute A or B or C? Does anyone want to hazard a guess? True? True? Awesome, you guys are correct. What happens now if I do A and B and C with the true, false, true? Right, false. Awesome, you guys are good in it. Of course, I already showed you the type. We can. So I'm going to introduce to you this really cool bit of code, which is the entire reason why we need all of this Boolean math in the first place. We can do things like, so let's say A is equal to 8 over 4 or 8 over 2 times 2. There is a piece of code in Python known as the if statement. And what that lets us do is it lets us execute code only if something is true. So let's say if A is equal to 4, notice the double equal sign over here. That just tells it that we want to check if A is actually equal to 4, not that we're trying to set A equal to 4. You'll notice when you hit enter after that, and you have the colon as well, it'll put you in a new line and it'll tab it over slightly. And inside of this tabbed area, we can place things, whatever we want really, that would only be executed if A is equal to 4. In this case, I'm going to have it print out the word hello. And as a result, you can see A is equal to 2 by 2, which is 4. And if A is equal to 4, it prints out hello. If I change this ever so slightly, and I do A equals 2 by 3, and I check if A equals 4, blam, there's no output. That's the result of using this if statement. What if I wanted something to happen only if A isn't 4? Well, I mean, I could do if A not equals 4. Note the exclamation mark here for not. I can even just do if not A equals 4. Print goodbye. And that part will execute fine. It's usually a lot more convenient and a lot more time-saving just to use the word else. And what else means is if that part wasn't true, then just execute this else part. And you can see it also still prints goodbye because A isn't 4, so it skipped this line, and then it went to the else and it printed goodbye. And just to prove that this is working, let's go a equals 2 times 2 again, and it's back to hello. Is there any questions about this? Awesome. Also just do, as with before, with the whole chaining ands and ors and whatnot, you can also do it in here. So if a is equal to 4, or if a is less than 3, I guess. As with before, if it's exactly equal to 4, you still get hello. If I set it to something that's less than 3, you still get hello. If it's not 4 or less than 3, you get goodbye. Does anyone want to hazard a guess what will happen if I do a equals 3 here? Goodbye. That's correct. And the reason, of course, is that it checks if a is less than 3, not if it's less than or equal to 3. If you want to do less than or equal to, it's just a little equal sign after that, sort of like an arrow. And you get hello again. All right, awesome. So, so far, all of our variables have just stored one number at a time. Here at Data Carpentry, we're mostly interested in the big data side of things. So let's start by going with how to store lots of variables without having to give a name to each and every single one. So another data type inside of Python is known as a list. Lists. And lists are variables, so you can give it any sort of name that you want again. I'll call it numbers this time. I'll use the equal sign to assign it again. And I'm going to use square brackets. Inside of these square brackets, I can just give it any sequence of numbers that are separated by a comma. And that's not going to output anything because I captured that. So in order to get it to print out, as you can see, it's memorized that numbers is equal to 1 through 5. If I wanted to, don't forget to put this near the top. I can access specific things from this numbers list. For instance, let's say I wanted to go and grab this 1 over here. Well, it's the first item inside of this list. And in Python, lists start from number 0. So number 0 will give me the 1 that I want. If I wanted to grab this 5, that's actually the 4th index because it's 0, 1, 2, 3, 4. So there you go. Numbers at 4 is 5. Python is start from 0. If you stick a negative number in here, it'll actually count from backwards from the end. So numbers at -1 is going to be this 5 over here. Does anyone want to hazard a guess as to how to access this 2 with a negative number? -4, correct. Cool. Next up, so we've got this list of numbers. Numbers is 1 through 5, which is great. But usually you want to execute one thing across all of the numbers inside of some variable. To do that, we're going to use a for loop. So a for loop is another special sort of command sequence that you can use in Python, which will go through some list and execute something or execute whatever you want for everything inside. So I'm just going to call it for num in numbers. Recall that numbers is our list from 1 to 5. And this num over here is going to be a variable. Every single time, so let's just print this out first. What this piece of code will do is it's going to go through this numbers list, which again is 1 through 5. And for every single time, it's going to store the variable, store the number inside of num, and then I'm going to have it print num times 2. So you can see with the output over here, we've got 2, 4, 6, 8, 10. That's because the first time it ran across it ran across the 1, multiplied by the 2, and printed out. Saw the 2, multiplied by 2, you got 4, 6, 8, 10, etc., etc. We can combine for loops and if statements however much we want. So let's say for num in numbers, I want it to print num. Sorry, so we got 1 through 5. Let's say I only want to print the numbers that are greater than 1. So if number is greater than 1, you'll notice that it added a second line of indentation over here. So there is another bit of white space over here, and that means that everything inside of here is inside of this if statement. So if num is greater than 1, then it prints num, and you can see it ran through my list of 1 through 5. When it came across the 1, however, it was like, oh, it's not greater than 1, just ignore it. Skip this piece of line of code. But for the rest of the numbers, it printed the exact number output. And of course, we can still use this else construct. So if num is less than or equal to 1, I can have it print out whatever I want, which is like, have it print out the word fits. Now you can see, when it came across the first one, this was false, so num wasn't greater than 1, and so it ran across this else statement and printed the word fizz. And so it prints fizz, then 2, 3, 4, and 5. And I'm sure now you can sort of see the coolness of this. Let's say if num divided by 2 is equal to 0, which is another way of checking whether or not the number is even. Sorry. Right, sorry, I need the modulus. To explain this one, there is a operator inside of Python known as the modulus. You might be familiar with this. It just returns the remainder after dividing. So in this case, the remainder of the number divided by 2, whether or not that's equal to 0. And if so, it prints out the number. Otherwise, it prints out the word fizz. And so for every odd number, sorry, it prints out the word fizz. Are there any questions with this? Because it's really complicated. Everyone good? Yellow sticky if you're good? Awesome. All right, that seems like everyone's following along just fine. I guess yellow sticky's down then, and we'll keep on going. So, number still contains our list from 1 through 5. The next thing that we'll learn is how to modify this. So the very first thing that we can do is we can do numbers dot append. Let's append the number 7. What this does, numbers at the end. What this does is it adds the number 7 to our numbers, to our list, which contains all the numbers. The cool thing is if I execute this multiple times, remember that Control-Enter is to execute, it'll continue editing this list, and it'll append 7 every time. Now our numbers array went from 1 through 5 to 1 through 5, 7, 7, 7. This dot append is what's known as a method, and it's a property of this variable that modifies it somehow, or that it makes available to you. To figure out what other methods are available for it, you can just do question mark. Sorry, we can use question mark numbers in order to figure out exactly what's in the list. I think you can do dot, and if you hit numbers dot and then tab, first as before, you can see all the functions that it allows you to do. Something like append, which is nice, clear, copy, count, etc. Probably also explain to append. If I hit Control I, and if I stop being in single, oh shoot, not this again. I hate this thing. Sorry, 1 second. I'm just going to reload this. Wait, sorry, cancel. I'm going to save this. And I'm going to reload this. Yep.
When we go from noun and numbers and follow,
yep.
The noun takes in values
from numbers.
Or is it the integers of the numbers? Or
it is the actual value of the number. So if I run this again, let's just run this particular line again. Now that it still have all those sevens, it's going to go fizz2, fizz4, fizz, and then these 4 sevens are odd, so it just prints out the number word fizz. Anyhow, I don't know how to spell the word append apparently. So if you hit Control I, you'll bring up this inspector view, which normally just shows up and replaces this thing. You can click and drag it wherever you want. In this case, I just want it off to the side. And as you're typing, it'll automatically fill up with the help of like the help info of whatever you type inside of here. Might have noticed numbers. It gave me exactly what's inside of here, which is to say, I type in numbers. It tells me that numbers is a list. It's got 1, 2, 3, 4, 5, 7, 7, 7, 7. It's of length 9, and it gives me some functions to operate with it. Do .append. It tells me that, oh yeah, you use the list .append, then you give it some number or some object, and it appends that to the end. If you want to do pop, it removes the last item or the number at index. So numbers, as we saw, is a list, and it stores a couple of numbers, and it allows us to edit the list, add to the list, whatnot. There is another type of variable called a tuple. And what tuples are, it's similar to a list, but you cannot change the values inside of a tuple after you declare it. So let's call this one like hi tuple is equal to 1, 2, 3. To declare a tuple, you use these circle braces instead of the normal. You use circle brackets instead of the normal square brackets. And I'm just going to have it output again. When. And you'll see that it outputs the same thing, but with bracketed numbers instead. You'll notice that there is no such thing as my tuple.append. It'll just refuse, mostly because the tuple doesn't support appending to it. But you can still access it just as you would with a list. So let's say my tuple at 0, and you can see that it grabs the first object, which is the number 1. Another cool thing about these tuples, I could also just give it like a bunch of string variables. And you can see that it stored the 2 of them. One other thing. Let's go back to lists for a second because I forgot to go over this. What was my list called again? Just numbers? Okay. Sorry about that. So our numbers is this thing. And our numbers at 1, or sorry, 0. It is the number 1. If I wanted to, I could edit this just by using the equals sign and then giving it some other number. Let's go 5. And then I'll have to print out what numbers is. And you can see now that it took the first item inside of numbers, and we have assigned it to 5. So now we can edit this list freely just by using this index notation. Question? Yeah. Sorry. Yeah, don't be afraid to interrupt me if I'm going in. Yes, sorry. Right. That is the next thing that I was going to show. So let's go with my underscore. Sorry, I'm going to scroll up. That's fine. Other tuple 0 equal 1. And you're going to see that it's going to fail. And it's going to give me this type error. Give me a second. Okay. Yes, question.
Is there a way to clear up variable any kind of attachment like I, J, you want to make sure that it's clear?
That it got deleted? Yes. And I always forget how to do it. It's del. So after running del and then going back to my other tuple, you'll notice it's like name error. My other tuple is not defined. And so what happened here is I took the variable my other tuple. It had apples and oranges in it, I think, and I deleted it from memory. That frees it up, and then afterwards, when you use it, it'll say it isn't defined. The same thing will happen. You get the exact same error if whatever variable you type in doesn't exist. There are some functions which will accept tuples only, and that's because you can rigidly enforce exactly how many things are inside of the tuple. Yeah. Any other questions? Cool. Without any further ado, then I'm going to go to, this is from the notes, and we've got 2 questions here. Challenge and the tuples. I guess just talk to the person beside you and discuss what the answer to these 2 questions are, which is to say, what happens if you use when you type a tuple at 2 equals 5 versus a list at 1 equals 5, assuming that this is a variable which contains a tuple and this one contains a list. And also, what happens if you type type of a tuple into Python? What's its object type? You might want to use these 2 things first. But yeah. Okay, great. So let's go over the answers. I'm just going to create a sample tuple and a sample list down here. I think you 2 are first. Do either of you 2 want to tell us what happens when you do a tuple at 2 equals 5 versus a list at 1 equals 5?
You type a tuple 2 equals 5.
Yep.
You type a list 1 equals 5.
Yep. Correct. And if I do a list, yeah, it becomes from 1, 2, 3 to 1, 5, 3. And for the tuple, it just failed to do anything at all. For question number 2, can I get a volunteer? Just raise your hand. Yes. So what happens if you type type of a tuple into Python? Yep, that is entirely correct. Whoa. Awesome. Cool. So yeah, that is entirely correct. You ask it what type of tuple is, and it gave you the answer as a tuple. So I guess without any further ado, let's get on to the trickier but also more useful variable types. And the first one that we're going to do is called a dictionary. Now, what dictionaries are is they're a type of variable which holds, you can sort of think of it as pairs of objects, one of which is called the key and one of which is called the value. So in this case, I'm going to initialize it like so, and I'll explain exactly what I'm doing in a second. So in this case, what I've done is I've created this translation variable, and I've given it this dictionary. Inside of the dictionary, there are things called keys, which are the things before the colon sign, and values, which are the things after the colon sign. Each key value pair is separated by a comma, and so you can see I've got two variables inside of this translation dictionary, 1 and 2 spelled out, and the values for each of them are the actual numbers 1 and 2. The reason why this is really cool and blows my mind every time is you can index through it just like you would with a list, but instead of giving it like 0 or like some number, you just give it the text that you had up here. So in this case, if I wanted the translation of word 1, I get this value, which is number 1. And if I gave it the word 2, I get the number 2. I could also do things like, let's say, like prices. I could go like, apples cost $2, and bananas cost $1. If I do prices of apples, of course, it's going to output 2, because that's the price of an apple out of this prices dictionary that I made. For bananas, it'll do a 1. You can sort of see that the power of this. Add in oranges, which also cost $2. So voila. So yeah, dictionaries are kind of like lists, but instead of doing indexing by numbers, you index by these words over here. The important part that I was trying to sort of show here is that this number afterwards, this 2, the values don't actually need to be distinct or unique, but do something like this, it's going to error out because it just says key error, but the actual error here is you can't have the same key inside of the dictionary. So I'm just gonna go back to having oranges, which cost $2. Just as with lists, what you can do is you can change the value of something just by getting at the thing that you wanted. So let's say prices of apples equals 3. Now when I type prices of apples, so again, I'm going to grab the apples from my prices list. I'm going to set that equal to $3 because of massive inflation. Now when I print out the prices of apples, it's going to give me $3 instead. It is, of course, possible to have other things as your keys. So I'm going to call this, we had translation up here. I'm going to call this reverse translation, or just reverse. And it's going to go from the numbers. Now if I do rev at 1, voila. I actually don't remember if I can also do like mix numbers and words. Yeah. So you can totally mix different types of variables inside of the key value pairs inside here. Key error, because 3 doesn't exist. It only gave me, I only defined what 1, 2, and the word words mean. There are some things that I won't accept. So I'm just going to make another one down here. So rev, call it bad equals, and I'm going to give it for a key an entire list. And it's also going to give me a type error. In this case, it's because it can't really figure out how to best interpret this in such a way that makes sense for a key. You'll notice that these error messages, A, they show up in red here, which is really nice for figuring out where exactly your code is going wrong. And B, it tells you the exact line where something went wrong. This one here refers to the first line of this code block. So if I did like equals 1, equals 2, that is equal to an error, equals 3. It's going to give me, it's this line right over here. It gives me an arrow exactly where the error is occurring. Going back to what we had earlier, we can still use for loops with these numbers, and let's go with prices. So for price in prices, I'm going to print out the price. Actually, let's call it price. You're going to see exactly what I did wrong in a second. It actually gave me the keys inside of the prices. So if you recall, I'm just going to put this here temporarily. Prices was my dictionary, which goes from some name to the value, or sorry, from some produce type to the exact cost of it. Apples cost $3. And when you do this for loop, it actually gave me the produce. And of course, get at the actual price by going through prices and then produce, which converts it back. So to break this up, produce is going to be equal to either like apples or bananas or oranges. And remember, this hashtag just means that I'm typing this out as a comment. So when I do like prices of apples, it's going to print out the 3. If I do prices of bananas, it's printing out the 1. The prices of the oranges, it prints out the 2. A much easier way to visualize this is if I just do like print produce and then print the price of the produce. Okay, there we go. I printed out the name of the produce, which is apples, and then it printed out the price of it, which is 3. Then it went to the next produce inside of the price dictionary. Got the bananas, and it said that they cost $1. And then I went through the oranges and said they cost $2. Next up, I think, is a challenge. So just remember that rev, in order to keep just going to reassign rev for a second. I'm going to go to the next challenge. Can you slow down a bit? Sorry, yeah. Yeah, problem. Yes. Right.
So is that essentially just going like the index, like in the for loop you told it now?
Yep. I haven't exactly told it. Yes, yeah, you're right. So we never actually told it what produce is, but instead it just understands that it wants to go through all of the keys inside of my prices, and every single time it runs, it'll set this variable equal to that key. So in this case, I'm telling it to store whatever it would normally loop over inside of this produce variable, and then it sets the produce. But yeah, this is just a variable name. And for clarity's sake, I've called it produce, but I could just call it whatever I want, and it would still do the exact thing. Produce will store the keys. Every single time this runs, produce will be set to a different key inside of my dictionary.
Aren't accidentally the same stuff in Python.
Sorry, could you repeat the question?
Like for example, I think.
Oh, like the variable name, you mean?
Yeah, when you're listening. So it's not something that Python.
Generally for so one of the cool things about Jupyter Notebook is it's got this like code coloring thing. And so you might have noticed that the for and the word in are both in bold, but they're also green. And the word print is also in green. So I guess just make sure that it's not either bold and it's not green. Might be one way you could get around that. Any other questions? Cool. Let's go on to the next challenge. So again, just working with the person beside you, try and work through this challenge. First, checking what is inside of the variable rev, which is the name of our dictionary. We try to reassign the second value, and then display it again to see if it's changed. So everyone, put down your sticky notes from your laptops, and then I guess work with the person beside you to try and tackle this challenge. And when you're finished, put up the yellow, and if you have any questions at all, just put up the red, and one of the helpers will come and assist you. All right. It seems like the majority of you have finished, so I'm gonna ask for a volunteer to come up and do the code. Anybody can raise your hand with the yellow. Otherwise, I'm gonna pick it at random. Sure. So just please explain to everyone what you're doing.
Okay, so I'm assign applesauce to this key. So the key is 2. I need to put quotation marks for that. So yeah, applesauce is assigned to the key value 2.
Cool. Thank you. Everyone follow that? Easy peasy, applesauce squeezy. Sweet. It's also interesting to note that if you try to grab an index that isn't there, so let's say we've got rev at 1 equals 1, rev at 2 equals 2. To do rev at 3 is equal to lemon squeezy. Red is supposed to squeezy. And then print out rev. It assigned 2 to applesauce, or sorry, applesauce to the number 2, and it assigned lemon squeezy to the number 3. So an easy way to expand upon any of these dictionaries is to just, using this bracket notation, edit the list, or sorry, edit the dictionary. Is everyone cool? Is there any questions? Take down your yellow sticky note if you don't have any questions. Awesome. So next up, we're going to tackle another construct inside of Python, which is known as the function. Well, functions are pieces of code that we might want to execute regularly. So to start with a function, oh, that's way too far down. We use the def for define, which allows us to define the function. And then we give our function some name. In this case, I'm going to call it the add function. And I use circle braces. Inside of it, I'm going to, for now, define 2 variables. Actually, I'll type up the entire thing and explain it in a second. That's not how you spell that. Apologies, I'll leave this up for a bit, just so everyone can see it. So the def stands for define. It allows me to define some function. In this case, I've called my function the add function. The add function takes as arguments or as inputs 2 numbers, A and B. I've given it this little string over here, which says this function adds 2 values together. I've said that we should define a new variable called result, which is equal to A plus B. and that this function should return the result. And I'll go through this one more time afterwards, right as soon as I go through this, which is where I call add underscore function, 20 and 22. And I just printed out Z. As you can see, the result of this is 42. So let's go through this one last time and go through the exactly what it's trying to do. So first off, defining a function doesn't actually run it. It just saves it for later computation. In order to actually run it, we had to add this part at the bottom over here, which is called calling the function. So call the function. In this case, what we've done is we've called add underscore function with two variables, two numbers rather, 20 and 22. What happens next is it sees, okay, so you're asking me to run this function with these two variables. So it goes all the way back up here, back to where we defined this function, and it sets a equals 20 and b equals 22. It ignores this line, and we'll go over why we need this in a second. But it stores inside of results the numbers 20 and 22, and then it returns it. And by returning the result, it replaced this thing with the result of adding 20 and 22. So Z got filled up with the number 40. And then I just told it to print out 20 or Z, and it got 42. If I gave it another number, let's say y is equal to add function 10 and -5, I had to print out y. You can see that it, yet again, it edited Z and it gave me y. Actually, yeah. Z is still equal to 42 and y is still equal to 5. So this is the basics of a function. And because we have this nice little thing over here, to get more information about any variable or function, you can always just do question mark followed by the actual the name of the function or the variable. And in this case, question mark add underscore function. Right? Did everyone copy down the yeah, or this piece up here? Not yet. Okay. I'll give you a second. Question. Yes. Yes. You can call that whatever you want. I could call it something super confusing, and I could call it subtract underscore function when it's actually adding, and that will leave you with a nightmare like 5 months down when you return this code and you think it's adding and it's not. So it's usually a good idea to name your variables and name your functions something that you in 5 months or in 1 year can understand. Are there any other questions? Cool. So, oh yes. Right. Yep. Yep. And it won't execute it. Return the result, and it still reduced or did this. There's actually really a lot of cool things that you can do inside of functions. I could have it print out the value of a every time. And so voila. It printed out the number 20 because that's what a was the first time around. It printed out the number 10 because that's what a was the second time around. And then it output Z and Y. Yeah, really cool stuff. So again, if we add a question mark before the name of a function, it gives us exactly how to call the function. In this case, we defined add function given some a and some b. It has something called a docstring. And what the docstring is, it's actually this comment thing that I had up here. I'm just gonna put this down. This is sort of like a comment, except it shows up when you do a question mark for any function. And in this case, I wrote down exactly what this function is doing in plain English. You don't have to rely on the name of the function every time in order to get all the details in there. And of course, you can set it to whatever you want. So this is a docstring. I'll execute that. Now I'll execute this question mark again, and now a docstring is this is a doctor. It gives me the file that the function was defined in, which in this case is just this IPython notebook, and it tells me that this thing is a function. Yes. That is also another thing in Python, where if you have 3 quotation marks, it becomes or actually, I usually see it used just to like define multiple lines worth of a string, like A equals. Although I think you can do that with 1 too. Yeah. Okay. No, you can't. You need the 3. So reason being for that is now I can have docstrings which take multiple lines. This is the second line of the docstring. And when I do question mark add function, my docstring is now 2 lines long. So really just the 3 quotation marks allows me to do multiple lines. Any other questions? Yes. As a single quote? Let's see. Single quote. I believe so. Whoa, what did I do? Yeah, probably does. If I have it as a comment, sorry, I'm moving a bit fast. It doesn't recognize it. Any other questions about functions and docstrings? Cool. It is also, by the way, possible to see the entire source code of the function that we defined earlier, just with 2 question marks. So now it gives us, again, the signature, but it also gives us the exact source code, the exact code that we use to generate this function, which can be useful. So I guess next up, we're going to be talking a bit about packages. And this is also something that we briefly discussed last time, but we'll go over the exact thing here. So these functions are generally extremely useful, and some people actually make a living just writing functions for other people. The import command allows us to access something called a package. And what these packages are they're a collection of these functions and some other stuff. Through which we can grab all of it by using import pandas. Again, you might have seen for a while there, it said in open square brace star, and that just meant that it was loading. That's because pandas is kind of large and expansive, and it covers quite a lot of stuff, so it takes a while to load. Is everyone able to, does anyone get an error when they write down import pandas as PD? I guess put a yellow sticky up if you're able to do it, red if you're not. Just need to make sure that everyone is the next step. All right. Sorry. Awesome. Okay, so it seems like everyone's got it now. So yellow stickies down. I kind of just feel like writing down. So we're going to be using a Python package in order to be working with this data set. And it's a longitudinal study of the species abundance in the Chihuahuan Desert ecosystem near Portal, Arizona, USA. It includes a bunch of observations about plants, ants, and rodents from 1977 to 2002, and it has been used in over 100 publications. There is a link inside of the GitHub IPy page to the abstract of the paper that gave us this data source. And we're going to be working with data sets that have been pre-processed for easy usage by us. So the structure of this is it's going to be a CSV, a comma separated value file, and we're going to be studying the species and weight of animals caught in plots. It's got a bunch of rows for each animal, and the columns are going to include all of these different descriptors, like including month, day, year, plot ID, species, sex, etc., etc. So as before, we're going to be using read CSV in order to load all of this data in. And this time, the CSV file is at a different location. So I'm assuming you've all run the import pandas as PD. I am now, whoa, that's nice. Control A, Control C. I'm going to stick this link because it's sort of large into the, what do we call it? The Etherpad. From this line. So inside of the Etherpad, I've put in the piece of line that I'd like everyone to execute. And what that'll do is it'll download the CSV file, the data set that we're working with, into this variable over here, survey. I guess yellow stickies up once you've finished, if you're able to load that line, and red if you get an error of any kind. Also going to say, you should probably also just have print out the value of this immediately afterwards, just to make sure that it loaded properly. It might take a really long time, and you'll note that because of the star. But once it finishes, you should see a giant, wow, huge amount of data. Why are there 34,000 animals in this? Yeah. If you've got it working, yellow stickies up. If you're having problems, red stickies. But it looks like the majority of you have it. Yeah. Cool. Whoa, what did I do? Excuse me for a second while I, oh, not again. Why do you do this? Thanks. I'm just gonna save this. I'm gonna reload this. There we go, still loaded. All right. Cool. It looks, oh. Okay. So I just saw, I think, tea come in / coffee. So I guess we'll just have a quick 5-10 minute break. Enjoy your snacks available on the coffee tea. And we'll be back here in 5. All right. Is everybody ready? Cool. Start the next section. Awesome. So inside of this surveys variable that we just loaded a file into, you can see that it gave us this ginormous amount of output. And in fact, you can scroll up and down through it. You can also scroll sideways through it. And there are a variety of different information about each animal that was collected inside of the canyon. And we've got, if you scroll halfway down, you'll notice that it goes ... halfway through, and that means that it omitted 34,000 samples because that'd be way too much. You can, yes. Or just, I believe this exact file has nothing inside of it. Like it's just a comma, then comma, instead of the CSV here, which this thing interprets as nan. No, R should also be able to handle the missing values. And in fact, pandas, you might notice the way this is all structured is extremely similar to how R handles data frames. So if any of you are familiar with R, this is basically going to be the exact same thing. So continuing through this, and yes, as he pointed out, the sex and the hind foot length aren't always defined, presumably because whoever was doing this perhaps wasn't able to get up close to the animal enough to see its sex and hind foot length. Anyhow, so we've got this ginormous amount of data, which is all stored in this data frame. And just to go over a bit on what data frames are, it is, a data frame will always be in this sort of rectangular format. And by what rectangular, I mean that there are 34,786 rows and 13 columns. And it's not as though each row technically has a value for each one of these columns, even if the value that it has is not available, or not a number in this case. This is particularly useful because then we can do stuff like grab the sex of every single animal that we've seen, or figure out how many male rodents we uncovered throughout this survey, et cetera, et cetera. And so far what we've done is we've read in this using read CSV. So by default, actually, I think if you count this, you'll see by default, when it's trying to display, it'll do the top 30, yeah, and then the bottom 30. And this is just because Jupyter won't try to flood the terminal, flood the screen with this giant amount of data. However, if we wanted to just see what the top of it looked like, and we don't want to even see all 60, we can use the function head, or the method head, and that just grabs the first one. And I believe, yes, we can also give it a number inside of the head in order to figure out how many lines you want it to print. So if I just do head of 3, it just prints up the top 3 lines. If I try and ask Python, tell me, what is the type of surveys? It tells me that it is a pandas.core.frame.data frame. This is just some sort of this organization here is something internal to pandas that we're able to see just because we imported pandas a while ago. You can grab more information about this. Whoa. Using the method known as surveys. Also note, As with the first lecture, it's usually a good idea to just tab complete everything because unlike me, the computer doesn't make a lot of mistakes when it types stuff out. So yeah, thank you. I'm going to execute the surveys.info command. And what this tells me is it's basically just another summary of what's inside of this data frame. You can see that it's got all 34,000 entries for each one of these. It's got the data type for each column. Note that each column is supposed to have the same data type. So in this case, these top 5 are all integers, 64 bits. Species ID and sex or object. And we can see that it also tells us how many rows inside of this are not null. So we saw earlier that there were a bunch of sex that wasn't recorded, and so it can tell us that maybe about 1,700 of those weren't recorded. We only have 33,000 that were recorded. And the same thing with the other types. Floats, again, if you recall, just mean that they were floating point numbers or just decimal. Other cool thing is that it tells us that the memory usage is slightly over 3.5 megabytes, which is pretty impressive to track all 35,000 small amounts of RAM. There are a variety of other, yes, sorry, problem. Besides info, there are a variety of other functions that we can use in order to get some basic summary information about this giant data frame that we've loaded into memory. So I'm going to do surveys, thank you, dot shape. And what that tells me is how big, or what are the dimensions, surveys. There is also, note that it returned a tuple here, and that's because, there we go. We can now access, for instance, shape at 0 will tell us the number of rows, and shape at 1 will tell us the numbers of columns. I have the print statement here, so I don't have to keep on You can see I accessed the 0th element of this shape tuple and printed out 34,786. I grabbed the first element of this shape tuple and it gave me 13. And so that's the number of rows, and that's the number of columns. So that is some basic tools that we can use to give us information about the size of surveys. We can get information about the content of surveys using surveys again, edge, grab the first one, first time. We can do, oh, sorry, might be going a bit too fast. Surveys.tail, grab the last time. And so you can see this is entry number 34,000 to 34,785. 172, yep. So again, surveys.shape give us this tuple, which contain the rows and the columns. So I can just access them individually. I can grab the rows from the 0th element and 1 for the first element. You can use surveys.head to grab the first 10. You can go surveys.tail to grab the last 10. I'm just gonna stick these all in the same thing. Surveys.columns, which gives us, as you might expect, this list, which tells us all the different keys inside of the columns, or all the different column IDs. surveys dot index gives us the row IDs. In this case, we didn't seem to want to print out all 34,786 numbers from 0 to 34,786. So it just told us that the row IDs are an index that start at 0, that stop at 34,786, and that go up by 1 for every row. Yes.
So some of these methods are using higher brackets and some don't.
Right. So Y is sort of internal to how pandas works. In a way, you can say that columns. So I guess I should first start with explaining what this dot is. Essentially, what this dot allows us to do is it lets us access some either some function that is stored inside of this pandas data array that we found earlier. And if you have brackets around it, that means that internally it's calling some function to surveys. In this case, head and tail are functions because it'll, after you execute this command, there is some code in the background which tells it to, the same with our function, just like grab the first 10 and then return the 10 and then give that out. Some of them are not, and that just means that it's some variable that's stored inside of it, which doesn't require any code to be run in the background. So essentially what I'm trying to say is it's some background implementation, and if you want to, what do you call it? I think a good way to explain it. I don't want to open up the inspector again, but the inspector will be able to tell you exactly how that works. Like which ones should be called with brackets and which ones should not. Otherwise, it's just something you memorize or while you're looking at the documentation. Question?
As I understand, surveys is an extension of the class.
Yes.
That's pretty much what column looks like.
Yep. So in essence, Pandas has created this what's called a class, which is some collection of variables and functions. And then what we've done is we've read up a CSV file, which was at the link that you all copied from the Etherpad. And it's created this giant object with all of these variables and all of these functions inside of it, which we can then access and use as such inside of this data frame. I've been calling these variables of the function. It's the technical term for it is called like an attribute of it. So the columns are attributes of surveys, and the index is an attribute of the survey. But again, it's just a question of whether or not there's anything, any code running in the back. I've done info. Yes, what a question? Yes. One of the quirks about how the IPython thing, or sorry, the IPython code blocks work is that it'll only show you inside of this output thing over here the last value that you output or that you place inside of the code block. So if I the surveys.head on its own, it's going to output just the head because it's the last thing inside of this block here. If I did just the tail, it's going to give me the last 5. I'm saying 10, it's 5. Right. So yeah, the reason why it's not printing out either of these when I have it all in this one block is just because it's only going to print out the last thing that I put here. Unless you use, of course, the print command, which I've used a couple times. Oops. Now, in which case it prints out the table, and then it still printed out the last thing that was inside of that code block. Any other questions? Cool. So there's just two last things, surveys.info, which you've already seen. Which it just gives you all the columns and how many of them are null, which is the column data types. And surveys.describe, there it is, which will give us essentially a bunch of summary statistics about all the columns. Sorry, about the about like how many records are there? What is the mean of the record ID? That doesn't actually mean anything. What is the mean hind foot length of all the animals that we've seen? Along with the standard deviation, the minimum, and the different percentiles. That one's median. This is the maximum value, et cetera, et cetera. Yep. Whoops. So we got info and describe, which gives us summary statistics. Okay, so without further ado, at this point there is another challenge. So again, I guess working with the person beside you. Oh, how do I find the challenge? This is the wrong thing. Yes. Not it. Okay. So based on the output of surveys.info, can you answer the following questions? I'm going to copy and paste this over to the. These for below. So based on the output of surveys.info, can you answer the following questions? What is the class of the object surveys? How many rows and how many columns are in this object? And why are there not the same number of rows for each column? I guess work with the person beside you and put your yellow sticky up when you have all three answers, and red if not. Any further ado, can I get a volunteer to answer question challenge number 1? Yes.
Yeah, the classes and for the frame or data frame.
Right. And how did you find? Oh, I guess it was inside the info.
Yeah.
Awesome. I'm just gonna do this just to show. Whoa, that's not how you spell info. Yeah, and so you can see the class is printed right at the top. And as before, the exact reason why there's so many dots here and why it doesn't just say the data frame is because it's something internal to Pandas library. And how many rows and how many columns? Same person, sorry.
3, 4, 7, 8, 6 rows.
Yep.
And columns 3.
Right. And then, do you know why these numbers aren't all the same as the number of rows?
Yeah, some have now.
Right. They're missing values. Either because, I guess in this case, like the animal might have escaped halfway through, so they managed to figure out the trap was tripped and which animal did it, but they weren't able to tell the hind foot length or the weight. So cool. I guess next up, we are going to. Sorry, is there any other questions about like the output of info or anything? No. Awesome. Let's continue going then. So it is possible to save all these files to your computer using the .2csv command. There's actually a lot of commands here, so I just hit q underscore and hit tab, and it auto-completed. And you can see that there are a variety of file formats that it lets you output to. It even lets you output to Excel, which is not something I've ever tried. HTML, JSON, LaTeX, etc. In this case, we're going to output it to a CSV file. And first thing that the 2CSV requires is the name of the file. is the name of the file that we're going to output. So I'm going to call it surveys.csv. And this is a quick implementation detail. We're going to say index is equal to false. The index in this case is the row numbers, and it wasn't part of our original data set. Python just added that in so that it could work with it. But in order to stay true to the input file, I'm just going to go ahead and say index equals false. I'm going to execute this. And of course, there's no output because it doesn't actually tell you what it did. But inside of here, it's like this. Yeah, there we go. So at the left over here, you can see your file browser. And inside of my current directory, you can see that it output this surveys.csv file. I guess I'll just open that up in Notepad just to show you what it looks like. One moment while I adjust the font so that this is actually visible. I'm just navigating to where the school is. A, B, C, D, E, F, G. Where on earth did it save? Oh, right. Sorry, it's not a text document. Haha, there we go. This is going to take a while to load, but essentially what you see, I'm going to turn word wrap off, is it's a comma separated values file. So each column is separated by a comma. The column names are at the top. It goes record ID all the way through all the commas that all the column names that we've already seen. And on each line, it gives us the exact value for each one. And you can see our missing data just shows up as blank here. Just to show you guys what would happen if I didn't have this index equals false. I'm going to open this up again in Notepad. And I'm going to up the font. I'm going to wait 10 years for this to finish. There we go. Now where's that? And you can see at the start over here, it just gave us this nice little number which counts upwards from 0 and which has no value for the columns. Cool. Does everyone understand first off, does everyone understand how to read this file? Like it's just commas separating the columns. Cool. Lastly, the reason for this comma index equals false is because we don't want that number at the very start of everything, because that gets added by Python. It doesn't part of our original data. So I've shown you how surveys.tocsv works. Now I'm going to try and load this file. So I'm going to call this surveys2 is equal to PD, which in this case, if you recall, way up, sorry, I'm going to go back down in a second, but if you recall, before the break, when we imported pandas as PD right over here, where pandas is the library of data frames that we're working with, and PD is the nickname that we want to give to it because I don't feel like typing pandas every time. So going back down, somewhere down here, okay, it's equal to PD dot read. I'm going to hit tab just to show all the different types. In this case, I want to read a CSV file. And I'm going to load up the file that I just wrote. And just so I can see exactly what happened, I'm going to give out the header. There you go. Surveys_2 is equal to this file as read by pandas. And if we read out the head of it, you'll notice it looks the exact same as surveys_1, except for this. I'm not entirely certain why that happened. Oh yeah, I forgot to rerun this line, the index. Thank you. There we go. Yeah. Index equals false. And then when you read it, it doesn't have that extra line. Cool. So if we're all on the same page, let's move on to how to manipulate these data frames. And this might seem really familiar to you if you're familiar with how R handles data frames. Firstly, we break out our trusty square brackets, and we give it the name of a column that we're interested in. So in this case, if I wanted to just grab the species from surveys, I would use the square brackets. I would remember to use quotes because it's a text thing. And I'm going to grab the head. And as you can see, I get a bunch of albigulas, which are the corresponding to the first four entries of this file. You could put whatever you want in here. So if I wanted to grab just the month column and just the first 5 entries, you can see, yeah, 7, 8, 9, 10, and 11. And since Jupyter is aware of exactly what's inside of surveys, you can always do the tab completion question. Yes. Sorry, could you repeat that? No, it goes up to 12. Sorry, 1 second. I'm gonna surveys month. Yeah. Oh, yeah. Sorry. This column right over here is just the row number, which starts from 0. This second number at the right is the actual one. And just to show you, let's go to surveys ahead. The month goes all the way up to 12, and it starts from 1. And yeah, 7 goes all the way up to 12, and then back down to 1. No, it means that the 0th row, which is the very first observation in this file, has month 7. And I can go back to here and you can see it as well. 7, 8, 9, 10, 11, 11, 12. 7, 8, 9, 10, 11, 11, 12. Sorry, was there another question?
I was just wondering if you can omit the index and just show the month.
Just show the month. I'm not entirely certain if you can. Let's still first do that. Not aware. Do you know? Values? Interrupt. Oh, cool. Yeah. You can see it goes from 7 to 9. We'll go 0 to 9 again. There we go. But yes, it is possible. Cool. I'm also going to just show it off, species underscore ID. Dot head. Just because this isn't a number, each row is still the 0 through 4. But in this case, it also tells us the name of the column and the data type of it, which is apparently object. String. This is just how pandas deals with it. let's say you wanted to grab more than one column at a time. That's easy enough to do. We still do the square brackets in order to grab at certain indices. But we're going to put another set of square brackets inside of that. It's basically like an array of all the things that we want. Or sorry, a list of all the things that we want. So in this case, I want species ID. I also want the record ID. Sure. And let's just print out the top 10. Come on. Print out the top 5 species and the records. You might have noticed that these two look slightly different. Yeah. Oh, yes. Sorry. Question. I don't think you can. No. Although. So sorry. I'm just going to keep it like this. Right. Right. And I'm pretty sure you also need like, just do it by number. Yeah. So, oh, that's right. Lock. Okay. We'll get to that. Sorry about that. The only other thing that I wanted to note was that these two output files, or sorry, these two output lines are displayed slightly differently. And that's just a technical detail of how when you only gave it one column, it gives you something of type series, which I'll just, whoa. Species ID. It gave me a series, which is sort of like a one-dimensional vector, or sorry, a one-dimensional list that Pandas uses internally. But if I gave it, asked it for the type of surveys, but I gave it two things. You can see it, two columns doesn't exactly fit inside of its series data type, so instead it gave me a data frame. Won't really be going over, we'll just sort of gloss over what the differences are, but if you wanted the series to be a data frame, you can. I'm just going to copy and paste that piece of code and .to_frame. And you can see that it switched it from a series to a data frame. And in fact, if I remove the tape, it'll display it as though it were a data frame. Is everyone clear? Or are there any questions? Yes. How far? Are there any other questions? Yes. There are some functions which only operate on data frames, and you'll see those when you're crawling through the Pandas documentation, whether or not it requires a data frame or it's just a series. Well, apparently there's a whole bunch of, a lot of them will accept both. Okay, so assuming that everyone's finished typing, Next up, we're going to go through the loc command, which stands for location. So by default, the loc command will grab a specific row. I should start from 0. And in this case, you can see it grabbed all of the columns for one particular row here. It's somewhat important to note that the indices, both the column names and the row indices, are all going to be unique. So you'll never get two different records just from using the .loc command. And of course, yeah, you can just switch that number to whatever you want. Yeah. We can also use .loc in order to grab a series of rows. So normally useful to grab the first 3, and you can see right over here, it's just grabbing the first. This is called slicing, if you're familiar with how R handles data frames. We can also, oops, sorry, just leave that one as is. Oh, sorry. We can also use .loc to grab both certain rows and certain columns. I kind of forgot to explain what this is. This just means 0 to 2. You can also just do like 0, 1, 2. Yeah. And so to grab specific columns, after you give it the rows that you want, you put a comma, and then you give it the column that you want, or columns. And if you want to specify more than one column, of course, just as with before, you can do this. Let's go species. Oh, now we can see the first 3 records and their species. If I'm not mistaken, it could very well be. Yeah. The columns have to be specified by their names, I guess. Oh, right, time law. So, without any further ado, there was another challenge, unless there was any questions. Yes. Name. Oh, got it. Including or without the. Got it. Yeah. This gave us everything from the record ID up to the species. Wait, up to species. Wait. Yes, yeah, there was the question earlier. Awesome. So if everyone has copied this line down, time for another challenge. This is the wrong thing again. Here we are. This challenge is a bit long, so I'm gonna copy it over again. Mark down, paste it. Large. I'm just gonna zoom out slightly. Is this challenge readable from the back? It might not be. In which case, we'll just do one at a time. Can everyone at the back read it? No? That better? Good? Awesome. Okay. So challenge now, I guess work with the person beside you to create a data frame called surveys 200 containing only the observations from row 200 of the surveys data set. Remember that Python indexing starts at 0. Do you remember how shape at 0 gave you the number of rows in a data frame? Try using this variable, this shape at 0, to pull out just the last row in a data frame, and compare that to the output of the tail command. And then create a new data frame from that row. Also, super challenge, what's a third way of getting the last row apart from using shape or tail? Remember how to index lists from the end. So I guess everybody put your yellow stickies down, and then you can put your red stickies up if you encounter a problem at any step in this process, or if you get stuck. And then when you're finished, all three, I'll put up your yellow stickies. Please explain as well.
Okay. Thank you. Fine and all right, printing in and circuits. 200.
Yeah, the home keys.
Yeah, I got P used in service.
Actually, though, I think that's. Sorry, this is wrong. So it's actually. This actually prints out everything past the 200th row.
Oh, I went further away. I should have gone 201 instead, or 200.
So we're only interested in grabbing the 200th row, just that one row.
But just the one. Yeah. Okay, so forget the. So you can just go on that.
Yeah, exactly. So in this case, grabbing just the 200th row would be .look 199. The reason why it's 199 instead of 200 is because Python starts from 0. You grab the first one, you enter 0. You grab the second one, you enter 1. You grab the 200th one, you put in 199. So this is question 1. Answer. Is there anybody here who wants to tackle the first part of question 2? Somebody with one of the yellow stickies up. You have your yellow sticky up. You finished? Awesome. Can you go?
Part of the challenge was surveys.
Oh, sorry. Yes.
Shape 0.
It's with square brackets.
Oh, sorry. That will turn that. And then, is that it?
We're looking for using that number to set just the last row of data. I'm just gonna.
Is tail.
I'm using the shape at 0 number to pull out just the last number in the data frame, the last row of the data frame.
Oh.
using shape at 0 for the last row of the data.
So maybe I didn't have it down. Surveys dot. Can I use LOC?
Yep.
And then square brackets, shape, square bracket 0.
Almost. You need to tell it which shape. So in this case, it would be surveys.
Surveys.shape. Like that?
Yep. So try it.
I think it did not go right. We are missing.
Right. Sorry. This is the dot shape at 0. So this is actually equal to 34,786.
Yeah.
So just start one up to that. You should be fine.
We're going in
After the first.
track one.
Sorry. But so between the two.
But like that?
Try it. Also, cool. So just to go over how that worked again, surveys.shape with the colon with the square bracket at 0 gives you the number of rows, which is useful, except in this case, the indices start from 0. So in order to go from pure numbers to the 0 index numbers, from 1 index to 0 index, you just have to remember to subtract 1 from them. And so this uses shape at 0 to grab the last number, or the last entry in surveys. And we can independently verify this by going back to the notepad file and say, yes, the last row has row ID 30986. Voila, record ID is 30986. I guess I can show you how this one works. Sorry, was there any questions about how this one worked, about how this particular line works? Is it crystal clear? So I'm going to compare that to the output of tail to make sure that we've got it right. And in this case, I guess I only really needed the last row. And you can see record ID 30986 down here, record ID 30986. Month 7, month 7. Day 1, day 1, et cetera, et cetera. So we can confirm that this piece of line of code has successfully grabbed the last line out of our file. Whoops. Yes, so whoops, sorry, I got you to do this question instead of this one. Does anyone want to, I really wish this thing would stop double clicking. Does anyone want to perform this fourth line down here to create a new data frame object from that last row? Somebody has anyone finished this one yet? Creating a new data frame object from the last row. Yes, give it a shot, please. Any other questions? That's the thing we should. Okay, just pull down. Oh, okay. Do survey. Creating a new variable called the survey underscore last, and equal to the surveys at the location of final row. Again, using the same index takes converting it from a series to a data frame. Voila. We can see yet again, we've got the right record. Thank you very much. The correct record, the month, the day, the year, and all of that printed in this format because he converted it to a data frame. Is everyone clear with that? I'll just give you a couple seconds to copy that down. And in the meanwhile, is there anybody who's finished the third question of this challenge, grabbing the last row without using shape or tail? Yes. Yes. And sorry, you had a question?
Oh, yeah, it's okay if I don't get a change the name of variable.
If you don't, sorry.
Change the names of variable using the title.
Yes, I think so. Yeah. Probably using the eyeball.
Tell me if this is wrong.
Hit Control Enter.
Sorry.
That's right.
Two frame?
Oh, sorry. I think some of that got cut off. The end bracket, the square bracket. Yep. Cool. Thank you. In this case, I think get by without using your hand. Yes, and so in this case, we're using the -1, which is just how Python goes from the end instead of the front. We're also using ilock instead of lock. I don't remember all the details between ilock and lock. Yep. Okay. The same number, right? Cool. Yeah, that is a good point. If you recall, our index, sorry, not our index, our rows. 1 second. Which was called? Sorry? Oh, right. Our index of surveys goes from 0 to 34786. So technically using .loc, so the .loc takes in the actual row number, right? The index, and surveys.iloc takes in the actual that is the difference between loc and iloc. Loc takes in the row index, which is only defined from 0 to 34786. But since iloc can take in numbers, we can give it negative numbers, which will let us go from the end. Cool. Sorry, are there any questions about iloc, loc, or any of the challenge questions? Yes, no? Yes, question.
I was trying to figure out the first question.
Yeah.
That made survey underscore from 199.
Yeah.
So, but it didn't copy the indices. It says that if you do the index.
Yeah. So yeah, what you did then was survey underscore 200 is equal to surveys from 199 colon. Right. Right.
And then, but if you do this survey as to 200 dot index, they start from 199.
Right.
Doesn't start from 1.
Right. And that's because the row names of this now. So I'm going to do head again. Actually, this is a really cool point. You'll see now that the row names still kept the 199 up to 203. Right? I suppose you can set the dot index equal to 1 through, or sorry, 0 through, what do you call it? 3, 4. What's shape of it again?
Or maybe just 0, 1.
Is there also a reset index? Yeah, there is. Sweet. That being said, this is actually a great demonstration of the difference between loc and iloc. So now if I just do loc at 0, it'll say, whoa, row 0 doesn't exist. What are you talking about? If I do iloc, it's definitely understanding that it's just the first row from this object over here, despite what the naming convention is. And that's also why the -1 works. Are there any other questions? Concerns? Everyone good? Cool. So continuing forwards, I am going to, let's take a look at what's inside of surveys one more time. So we've got all of these different variable types, all of these different columns, and we know that let's say the absolute minimum hind foot length is 2 and the absolute minimum weight is 4. Generally, we're going to want to plot the data in order to explore exactly what the relationships between all of these variables are. But before we start plotting, we should probably understand exactly how to manipulate the data to get only what we want. So we've seen splicing before, where we just grab it by index. It is usually also interesting to see other things aside of, other aspects of the data. So for instance, you can use Boolean operators like less than 5 or greater than 3 or whatnot in order to see, in order to obtain the rows which have only less, or sorry, I'm just going to execute this and I'll explain it. So I ran surveys, I grabbed the weight, and then I asked it whether or not it was less than 5. And you can see for the first 30, none of them were. And for the last 30, none of them were either. Let's just let's go with surveys.head. Double check to see what's at the top of this again. What is defined? Let's say I want all the entries that had a month before November. So in this case, I'm going to go surveys.month. Less than 9, for instance. You can see after I execute this, the first 2 rows are true, and it tells me that they were true because the month was less than 9 for them. and then for the subsequent 5, it's false because they were September or afterwards, et cetera, et cetera. The result of running this, of course, is about as large as the entire data set itself. You can see that it's a length of 34,786, and the data type is a Boolean. And so the output of running this one command was this series of Booleans, 34,000 long, and it's only ever true or false depending on whether or not the month was less than 9. We can use this together with the .loc command. So I'm going to five. That's right. And in this case, what happened is it grabbed us every row where the weight was less than 5. And you can see the very first instance of this occurring was at row 2428. We can do this with other things as well. Just to call back to earlier, copy and paste this. Surveys.loc surveys where the month less than 5. Right. And as before, grab the first 2, skipped a bunch, goes through 7 through 9, et cetera, et cetera. I should probably remember to use the .head, but it doesn't hold the terminal. Are there any questions as to what I just did? Yes, no, clear? Also, as before, we can combine this to look at specific columns as well if we're not interested in all of them. So I'm going to do surveys.loc, where I'm just going to stick closer to this, where the weight is less than 5. Now I'm really only interested in the weight along with which species they were in. I have too many. No, and so now we can see that inside of our data set, there are only a couple of species where the weight would go that low. We can, as before, give this into a variable. So capture the output inside of a variable, which I'm going to call small surveys. Whoa, surveys underscore small. And as before, there is no output because I've captured it. So surveys underscore small edge. Voila. Now you can just see the top 5. Continuing forwards, unless there's any questions about what I just did. So continuing forwards, we can combine different filters, just like the one we did up here, all at once. So what I'm going to do is, let's say I'm interested in surveys where the taxa is a rodent. And I'm just going to put brackets around this just so that Python knows not to try and expand this too far. And where and is similar to the and that we saw before with Booleans. Oh, sorry. and where the sex of the animal was female. I'm just going to split this into 2 lines. If you can fit this in 1 line, do, but I can't. And so what I'm going to do is I'm going to use this backward slash right before the new line. And that just tells it to continue reading past the end. I don't think that's necessary. So after running this, you can see I've grabbed only female samples and only red ones. I don't think this is necessary. Okay. And this sort of spills off the edge of the screen, so I'm just going to take the head. And suppose then I'm also only interested in the height. Then outside of this, I'm going to take just the taxa, the sex, the weight. Cool. You might have noticed that I am running out of space wildly in order to try and fit everything in. So it is possible to just place all these on different rows, so long as they're inside of these brackets, inside of a set of brackets. I'm just going to do a quick aside over here. Normally, if you have things on 2 different lines, Python will throw an error at you saying invalid syntax. What is this new line doing here? There are 2 ways of getting around this. You can either have a backslash before the new line, before hitting enter or return, and it'll continue reading off the second line as though it didn't see what you had, or as though it didn't have the new line, rather. Another way is to just have brackets. So just a quick aside. 2 ways of fitting across 2 lines, 1 plus slash 2. Really having brackets. Question? Yes. Okay, so there is a, so let's put it over here. Difference between and the difference has to go with, I think it's with lists, I think. Nope, you can't do that. List and list. I believe, I thought and was for, would take the each list, but I'm not actually certain anymore. Difference between and, spelling it out. That only pandas does? Okay. True, false, and true, true. Thanks. I think we have time, actually. If you wanted to explain. Okay. Right. Oh, got it. Oh, whoops. Right. Got it. Mm-hmm. And the way to get the first thing to actually be false is, I guess, giving an empty list. Cool. Oh, that's a neat thing. So I guess to spell that out, all aside, let's say A and B. So by default, Python likes to convert things to booleans when you put them inside of the and thing, or inside of an or inside of an if statement. And by default, the only way to, so let's say I'm going to do A equals a list. A is true. So just a little bit of a test code. I gave A as a list. And if you do if A, all it checks is whether or not A is truthy. And by default, any list that isn't empty will be truthy, which is to say it's equal to true. If I remove this, well, it's no longer true. Default, what the and is actually doing under the hood is, let's say, I guess I don't really need that. So if A is empty, is an empty list, then it is falsy. By default, if A is falsy, then it and will return the first object, which in this case was an empty list. And if A is truthy, then and will return the second object. Now, if I set A to be truthy again, first off, the print statement still executes, and second off, the output of this final line is the second thing here, which is just a cool implementation detail. Did everyone get that? Not really. I guess this is not really something you'd run into very often, or the rest haven't run into it in all the years of Python. So yeah, just a cool implementation detail. That being said, I guess don't really worry about it too much if you don't get it. We'll just go forwards. Although I think we're nearing the end of the lesson. So I'm just going to copy what I had up here. So we've gone over how the and thing works, where this and means just do things where the taxa is rodent and the sex is female. The other thing that you can do is the or statement, and to do that, it's just the pipe. If you're not certain where that is, it's usually like right above your enter key, and you have to hit shift in order to do it. Does everyone see the or key on their keyboard? And the result here is it only grabs rows if the taxa is rodent or if the sex is female. Let's say if the species is Clarky, or if the species is Leucophyrus. So let's grab the actual species out. And so as you can see, it's grabbed rows where the species is Leucophyrus or the species is Clarky, and just grabbed the sex of the witch, which appears to be empty for them. So we've got, I think, the last challenge. No, second last challenge. So we have more challenges. First challenge is to switch this down to Markdown again. Subset the survey data to include individuals collected before 1995 and only grab the columns year, sex, and weight. I guess yellow stickies up once you finish that, red stickies up if you have a question or are otherwise confused. She's using surveys.book to grab specific records or specific rows. She's grabbing all of the years and seeing whether or not they're less than 1995, which puts that as she wants as. Oh, yes, sorry, do you mind if I Cool. Thank you very much. And so as you can see, we have in our new thing, only the years which are less than 1995, which includes a lot of 1997s, 1978, sorry. And we only have 3 columns, the year, the sex, and the weight. I'll give everyone seconds to copy that down. And then there's just 2 concepts and the final challenge. Okay, so assuming that you've all copied that down, so 2 last things. One is we're going to cover how to generate new columns. And so what you might have noticed is, I'll just take the head of this. The weight column is actually in grams. So suppose now that we wanted to convert it from kilograms to grams, all we have to do is, just like with the dictionary, we open up new braces and then we type in a new column that we want to add, weight underscore kilogram. And in this case, all you have to do to convert from grams to grams, take the weight, divide it by 1,000, and it's gonna not really show me a whole lot, but all that did is, if I scroll to the right, this lets me scroll to the right, you can see I've got this weight underscore kilogram thing, and just gonna, for this row right down here, you can see that the weight used to be 218, and we've created this new column called weight underscore kilogram, and it's just equal to that divided by 1,000. Yes. Awesome. So there's just one last thing. You might have noticed that I've had a whole bunch of these nans over here, and they're kind of really annoying. So what I'm going to do is we're going to introduce the drop NA command. And all that does is it removes all rows where there was at least one missing value. Now you can see in a much better way that the weight underscore kilograms is just equal to the weight divided by 1,000, as we coded. Sorry, Apple screen, this one. Okay. In fact, I'm just gonna bend those two. There. So again, we created this new column, weight for kilograms. We set it equal to the weight divided by 1,000. We removed all the NAs and then just printed out the top 10 rows. That being said, it is time for our final challenge of the evening. Here it is. All that we want to do is create a new data frame from the surveys data that meets the following criteria. It contains only the species ID and hindfoot length columns. We have a new column called hindfoot half, containing values that are half the hindfoot length values. And we want to remove all NAs and all values that are less than 30. This is a fitting final challenge because it adds a whole bunch of the things that we've discussed up to this point. And this is also the final part of our introductory data analysis section. So I guess yellow stickies down for now. Remember, you can use the red stickies to signify that you need help of any sort, and then yellow stickies up when you finish. Then after this, everything's done.